Hello, I'm Lingwei Deng. In this video, we'll delve deeper into the details of our NeurIPS 2025 Spotlight paper, SViMo, Synchronized Diffusion for Video and Motion Generation in Hand-Object Interaction Scenarios. Hand-Object Interaction, HOI generation holds significant potential in gaming, animation, digital human creation, and robotics. Existing 3D motion generation models rely on limited 3D lab data, hindering generalization, and video models lack physical awareness. Our insight is that visual appearance and motion dynamics share the same physical laws. We propose to unify visual priors and kinematic constraints through synchronized video-motion cogeneration. We propose SViMo, a synchronized diffusion model for HOI video and motion joint generation, consists of two key components. First is the video generation module. Given reference frames and text prompts, it generates interaction videos and 2D rendered motion videos simultaneously using a synchronized video-motion diffusion model. The results are then fed into the second component, the vision-aware 3D interaction diffusion, to produce explicit 3D interaction motions. Due to the coupling between components, the 3D interaction diffusion model backpropagates gradients to the synchronized video-motion model, providing gradient constraints. Furthermore, generated 3D motions are projected into 2D image plane and fed back to the synchronized video motion diffusion for direct interaction guidance. This design enables three advantages: end-to-end video motion generation, both visual realism and dynamic plausibility, and certain generalization capability. Here is the pipeline of our method. More detailed pseudocode regarding the training and inference processes can be found in the appendix. Next, we present results generated by our method. The first case involves the interactive task. Use spatula to scrape off pan. The leftmost shows our generated video, demonstrating strong visual realism. The middle panel displays the generated motion, which exhibits plausible movement dynamics. To further validate the alignment between video and motion, we overlay the motion onto video frames at the rightmost, revealing consistent between the two modalities. The second case involves the interactive task. Use spoon to scrape off plate. The generated results demonstrate good quality. The third case involves the interactive task. Use spatula to put out bowl. The results and conclusions are the same as those of the previous two cases. We next compare our method's video generation results with those of baselines. The first case involves the interactive task. Use bowl to put in plate. This is Huanyuan's result. It exhibits limited dynamics and hallucination issues in the latter half of the video. This is Wan's result. It hallucinates a third bowl with unrealistic floating motion. This is Animate Anyone's result. It shows strong frame flickering and object shape distortion. This is Easy Animate's result. Aside from temporal flickering, the object appearances are inconsistent in the video. This is Cogvideos' result. The motion of the bowl shows slight floating artifacts. Finally, our results demonstrate superior performance. The second case involves the interactive task. Use spoon to scrape off pan. This is Huanyuan's result. It exhibits low dynamics. This is Wan's result. It hallucinates non-existent rice and water flow. This is Animate Anyone's result. It shows strong frame flickering and object shape distortion. This is Easy Animate's result. Aside from flickering, the motion exhibits unrealistic abruptness. This is Cogvideos' result. The penetration occurs between the spoon and pan. Finally, our results demonstrate superior performance. The third case involves the interactive task. Use kettle to pour in plate. This is Huanyuan's result. It exhibits limited dynamics and hallucinates non-existent paper pieces. This is Wan's result. It hallucinates non-existent water flow and introduces camera shake artifacts. This is Animate Anyone's result. Persistent frame flickering and object shape distortion remain. This is Easy Animate's result. It hallucinates non-existent water flow. This is Cogvideos' result. Significant kettle deformation occurs between frames. Finally, our results demonstrate superior performance. We next compare our method's motion generation results with those of baselines. The first case involves the interactive task. Use roller to dust kettle. This is MDM's result. It generates motions with low dynamic, produces unclear point cloud contours, and shows position mismatch with objects in the reference image. This is EMDM's result. It exhibits significant shape discrepancy from the reference image, indicating low image motion consistency. Finally, our results not only exhibit plausible motion but also maintain high consistency with the reference image. The second case involves the interactive task. Use spatula to stir plate. This is MDM's result. This is EMDM's result. Finally, our results. The observed phenomena and conclusions align with case 1, so we present the results briefly. The third case involves the interactive task. Use spoon to put in bowl. This is MDM's result. This is EMDM's result. Finally, our results. The observed phenomena and conclusions align with cases 1 and 2, so we present the results briefly. To validate the model's generalization capability, we collected real-world data and performed zero-shot generation. The demonstrated interactive task is, use the spoon to scrape the bowl. This is the generated video. This is the generated motion sequence. Finally, to evaluate video motion alignment, we overlay the two modalities as shown in the rightmost. The visualization results demonstrate our method's zero-shot generalization capability. In addition to evaluating zero-shot generalization with real-world data, we also evaluate performance using the open-source HOI OKink2 dataset. The demonstrated interactive task is, use the cup to pour into the bowl. This is the generated video. This is the generated motion sequence. This is their overlay result. The visualization confirms our method's zero-shot generalization capability. Scan this QR code to access our project page. Thank you.